Hey guys, how are you all doing this week? So as you probably already know from my text that I sent out the other day, you're only going to be getting one lesson a week from me now. Okay, this is the way Putnam County Schools wants us to do this. So every Tuesday, you guys are going to be getting something from me. We are still going to follow the actual spring break that was outlined for us. I'm pretty sure that's next week, but if it's the week after that, whatever. I don't really know what it is. I'll have to look it up. But we are still going to follow the spring break that we were supposed to have. So whenever spring break is, I'm pretty sure it's next week. You will not be getting an assignment from me then. So just be looking out for that. So you will have 1 week to do this. That means I'm going to post it on Tuesday, so you'll have till the next Tuesday to turn it in to me. And that's all Putnam County Schools guidelines, and that's exactly how they want us to do it moving forward. Okay, so today we're going to talk about the law of cosines. Okay, the thing about the law of cosines is this is used whenever we're solving a triangle. These are the exact same triangles like we had last week when we were using the law of sines. The problem here is we don't have a control. If you remember back to the law of sines, we were always pairing up one of the angles with the side that is opposite it. So in our triangle down here in example 1, the control would have been the angle 42.3 degrees and then side A, which would be this location over here. Okay, but we don't have it as part of this picture. So the law of sines is used anytime you have a control. Law of cosines is used if you don't have a control. Okay, so there are actually 3 variations of the law of cosines. I'm going to write all 3 of them out, but then I'm going to talk about how they're all really the same. So the first one is a squared is b squared plus c squared minus 2bc times the cosine of a. The second one, b squared, is a squared plus c squared minus 2ac times the cosine of a. And the third one is c squared is a squared plus b squared minus 2ab times the cosine of a. Now, if you notice, all 3 of those formulas are the same. They're just set up for different variables that you're solving for, okay? So whenever I do this, I don't think about which formula I need to use or anything like that. I just know that I put the one that I'm looking for on the left, and then I know it's equal to the 2 sides that I have squared, and then minus the 2 sides multiplied together times the cosine of the angle that I'm looking for. Okay, so hopefully you should be able to figure that out about these formulas, how they're all 3 the same. You're just changing it around for what variable you're looking for. Now, let's look down here at example 1. So the easiest thing to go for in a problem like this is the side opposite of the angle that you already have. So we already have angle A, so I'm going to go for the side opposite it. So this would be side A, okay? Since I'm going for side A for right now, I'll use the formula that's set up for A, okay? So I'll set up my formula over here. A squared is b squared plus c squared minus 2bc times the cosine of A. Now I can just fill in all the information I need because I know, let's go with blue, I know this over here is side B. I know this is angle A, 42.3. I know this 15.4 down here is side C, okay? Because remember, uppercase letters are angles, lowercase letters are sides. So let's fill in the information we know. We don't know A. We know B is 12.9. We know C is 15.4. So then that's minus 2 times 12.9 times 15.4. All times the cosine of angle A, which is 42.3 degrees. If I'm intelligent enough to type this into the calculator, I've pretty much got A, okay? Right now we're going to get A squared, but that's okay. So I'm going to type in the whole right side. I've got 12.9 squared plus 15.4 squared, and then I'm doing minus, I'm going to wrap all this up in parentheses just to make sure it's getting in the right places, 2 times 12.9 times 15.4 times the cosine of 42.3. Okay, so let me make sure I typed it in right. 12.9 plus 15.4 minus 2. Yep, we're all good to go. So 109.69 is what I came up with. So, but then that's A squared. Okay, so that is A squared is 109.699. Okay, I'm going to go with 69. But in order to get A, I'm going to have to square root. Okay, so A is then going to be the square root of that, which is 10.47. Okay, now I should probably look at the way my rounding is on my picture. Each of those is rounded to 1 decimal place, so I'm going to go ahead and round that to 10.5 when I put it on my picture. So I'm going to get rid of this red A, and I'm going to put it on my picture as 10.5 meters. Okay, so that's not too bad. This is the way that all of your problems are going to be set up today. Okay, so all of the problems this week, you're going to have an angle and two sides. Okay, so everything will be like this. You can just set it up for the side that you're missing. Remember, the reason I went for A here, the reason I used the A formula, is because that's the angle I had, and it was easier for me to just find the angle, find the side across from the missing angle. Okay, so now I have this information as part of my picture. Okay, what I have to do now moving forward is finish out the rest of this triangle. But notice now something. You have a control. Okay, so this reverts right back to what we did last week with the law of sines. Get that off of there. This reverts right back to what we did last week with the law of sines because I already have a control. So that's the thing about the law of cosines. Once you do your first part of it, you really don't have to continue doing the law of cosines. You could if you wanted. It'd be a pain in the butt. But you don't have to continue. You can just revert back to the law of sines because now you found yourself a control. So I'm going to use the law of sines for A as my control. So sine of A over A. Let's say we want to go for B next. Let's go for angle B. So this is the guy that I'm looking for right here. Okay. So I'll say sine of B over B. All right. So sine of A, let's go with, let's fill in the information. Sine of 42.3 over 10.5 is sine of B over 12.9. Okay. I will cross multiply here. So 10.5 sine of B is 12.9 sine of 42.3. Let's get rid of 10.5. So I've got sine of B is that big old thing, so 12.9 sine of 42.3 all over 10.5. And we talked about the other day, in order to get rid of the sine, you have to do the sine inverse. So B is equal to the sine inverse of all of that up there. Okay, so I'm going to type that in. I'm going to say sine inverse, I'm going to give myself a fraction bar, 12.9 times the sine of 42.3 all over 10.5. Okay, so that gave me 55.77. B is, let's see, my angles are rounded to 1 decimal, so I'm going to go 55.8. Okay, so now the other day, though, we talked about how if you were solving for an angle, so if you had to take a sine inverse, then there's a second angle that also exists on the other side of the unit circle, if you remember that. So the way that we got that other angle is we took 180 degrees and we subtracted that angle that we just came up with, 55.8. So that's what I'm going to do real quick. So 180 minus 55.8, that gave me 124.2. Okay, so let's just consider if that's a reasonable situation. 124.2 being the second triangle, if I add that 42.3 that's already up there, that gives me 166.5. So if I take that away from 180, that's only going to leave me with 13.5 degrees for C to be, and C is obviously the biggest side. Okay, so the biggest side would never be able to go with 13.5 degrees. Okay, so that's why there's no second triangle on this. You'll want to check that, okay? Most of the time it's going to turn up no, but every once in a while it could turn up for a triangle that exists. Okay, so on ours, there was no second triangle that existed. So I'm going to go ahead and put B up in my picture, 55.8 degrees. And now my problem is very simple. If you want to do the law of sines again to find C, you could, if you really wanted to. But that seems unreasonable to me because you could just subtract both of those from 180. So I'm going to go 180 minus 42.3 minus 55.8. That gives me 81.9. Okay, so just a little bit under 90 degrees. and I have solved my triangle. So that was the idea here. We were trying to find all of the angles and all of the sides for our triangle. Remember, it gave us angle A, side B, and side C. And remember, the reason that we had to set up the law of cosines is because we did not have a control. Okay, so the red right here, oh, hang on. The red right here was the first, sorry, I don't know why this thing keeps moving on me. I'm going to say it one more time and it's going to work this time, I promise. The red that we solved for right here was the first thing that we solved for using the law of cosines. Okay, once we got that, it gave us a control so that we could use the law of sines to find the rest of the information. Okay, so set up your problem based on whichever formula that you need. And again, it's easiest to find the side that's opposite the angle that you already have. Okay, so you should be able to do this pretty easily. This is just another way of solving triangles based on different information that you're given. Next week, I'm going to give you another piece of information different, and we'll solve it just a little bit differently. Okay, so for this week, what you got to work on is page 319, numbers 13 through 14, and 19 through 22. Okay, I considered doing a few more, but we'll just go with this because I think 6 is plenty for you to get the idea here. Remember, if you have questions, just text me, and I should be able to answer them. I'll just draw you a picture. I'll write something out, write some instructions on it, and then I'll just send you a screenshot right back. Okay, so let me know if you need anything. Again, you have 1 week to do this, so I'll grade it next Tuesday. Okay, so 1 week from today, and everything should be good. Okay, so I don't like only talking to you guys once a week, but this is what they've told me to do. So I will see you guys next week. I really don't know when spring break is. If it's next week, I won't talk to you till the week after that. But whenever it is, we will do it. Okay? I'm pretty sure it is next week. All right. So I will talk to you guys after that. I'll see you.